Hello, my name's Abhinav Ojha, and this is Lab 3. The first thing we did was we built a 4-bit deregister with an enable. This basically, uh, so if you put 8 here, enable, and the clock cycle, output will be 6. If I turn enable off, and if I make this, I don't know, 9, no matter what I do with the clock, on and off, every clock cycle, it will stay 6, unless I press enable again, and then it will override it. Unless if I want to make everything 0, I can just press reset, everything becomes 0. That's what these clears do. Um, that was it. And then we had to do the GTK wave. So here's the waveform for that. It's doing exactly what I just did. So input is 1, enables on. After the clock cycle turns on, then it becomes 1. Then you reset it. Then the next test was the input became 15, enabled on. After the clock became 15, then the enable turned off, so you can't write this anymore. So no matter what they did with the input, it stayed 15. Then it was reset, and then 10 was put into the input, enable on, so at the clock cycle, the output became 10. Then we bit the 4-bit up counter. So this basically just incremented up by 1 and looped. So it went from 0 to 15 and then back to 0, 15, 0, 15. So if I press enable on, so at every clock cycle, it will go up to 15 and then go back to 0. If I turn enable off, no matter what I do with the clock cycles, no matter how many clock cycles go by, since enable is off, it will not increment. And then reset will reset it to 0. Um, then we worked on the RAM. This had addresses here that we preloaded, 3 and 5 and 0 and 1. So what we did was, if I write 0 here and let's say I want to make this 8 here, and I want to write into the address of 0 here, and I want to write 8 into it, when the clock cycle runs, it becomes 8. If I want to access the information, then let's say I make the address 1 and I make this 0. Clock cycle will give me 1. Give me 5 because that's what's in the thing. So if I make this, I don't know, 4, it will give me 0 because that's what's in that address. But if I want to write, let's say, 11 into that, then I turn right on, then it will write 11 into 4 right here. So that's what this one did. Then we worked on the brainless CPU. Here, it'll be much easier to explain this with the test cases and the waveform, but basically it can read data from the RAM. It can use that data to go to the accumulator. You can use that data to override stuff. You can take data in and write it to a specific address in the RAM and use it for later use. That's basically what this does. So the first waveform was the one that that the assignment gave us, which was the arithmetic add. So what they did was they gave us first they reset everything, then they loaded in 3 from the RAM, which because we're initially giving the address of 0, 3 and address of 1, 5, they were able to, with the address of 0, they loaded 3, and then the address of 1 in the next cycle they loaded 5. That's what they did, and then because they had arithmetic on, what it did was it added the numbers together. So 5 plus 3 equals 8. So the accumulator was 8. But because the clock cycle turned on, what happened was it became 8 plus 5 because of this here, 8 plus 5. If you just look straight up and down, it became the ALU out is currently 8, currently D, but the accumulator is still 8 because that was the answer we were looking for. Then I made test cases for the internal writing, external writing, and the ALU. So in the internal writing, here, what I did was I took data 10, and then what's it called? I passed it through, so the ALU out was 10, and the current data is 10. Then what I wanted to do was I wanted to load the 10 into the accumulator. So that's when I turned load accumulator on and pass on at the same time. So I loaded 10 into the accumulator. Then I wanted to not have any data into it, into the input. Now I wanted to put the data from the accumulator into the database. So that's when I removed the data in and I removed to loading accumulator, etc. And then I wrote 10 into the database. And then what I do is then I just read from the database and then I reset and do nothing. So the waveform for this one looks like this. So here uh, I inputted 10 and then I passed it so the current data and the ALU out is also 10. Then I turned load to the accumulator on. So at the clock cycle, the accumulator became uh, 10. Then I stopped giving it data and stopped passing and I stopped loading to the accumulator. Then I told it to uh, write from the accumulator to the database, and then I told it to write it. So what it did was it wrote the accumulator into the data bus, and then after that I told it don't load or write anymore. I just want to read it. So then it read the 10 here. And then after here, I reset everything, so it's good to go. Then we did the external write. This is just writing straight from the data into the RAM. So here we give it input of 10, and we told it to write. So it writes to the data base at address of 0, 10, and then we say I don't want to give you any more inputs to tell you to read what I just gave you, and then it says okay, read from the address 0, and it gave output of 10 here. Then the ALU here, this one I just inverted it and stored the 5 into the accumulator. So here I gave it 10 as an input, told it to invert, pass, and load it to the accumulator. So the ALU out is 5, and the current data in the data bus is 10. But since I told it to invert and load it to the accumulator, at the clock cycle, the accumulator is now saying 5. Then I reset everything and I called it as 0 for everything else. There was nothing else wrong. I faced no issues except for just creating test cases, and that is it. Thank you.